Some animals benefit from the ability to perform multiple modes of locomotion. For example, insects often use flight to travel long distances, and legged locomotion for behaviors such as nesting and foraging. A robot that could fly a long distance to a target area, land, then walk over unstructured terrain would find considerable utility in first responder and reconnaissance operations. BioRobots LLC, in conjunction with the University of Florida, Case Western Reserve University, and Naval Postgraduate School, is developing MALV, Micro Air Land Vehicle. MALV's aerial locomotion utilizes the micro air vehicle technology developed at the University of Florida. The central feature of the UF-MAV is a flexible, undercambered wing reminiscent of a bat. This design allows the wing to respond to wind gusts with passive adaptive washout, thus increasing the vehicle's stability at lower speeds. For terrestrial running gear, MALV employs MiniWig's locomotion technology, developed at Case. MiniWig's wheel legs combine legged mobility on rugged terrain with the operational simplicity of a wheel. MALV's fuselage is composed of carbon composite, combining lightweight with high strength. Flight maneuverability has been achieved using both rudder elevator and aileron control. Terrestrial locomotion is accomplished with the addition of two 3-inch diameter wheel legs at the front of the vehicle. Each wheel leg is driven by a separate RC servo that has been modified to allow continuous rotation. Steering is accomplished through differential activation of the wheel leg drive motors. Insects fold their wings when they are not in flight, which reduces their size and protects their wings. We are developing folding wings for MALV so that it can also morph its shape and crawl through smaller spaces. MALV is manually launched, but after performing a reconnaissance mission on a roof, it can regain flight by walking off the ledge of a 2-story or taller building. Here, MALV is shown performing a simulated mission to locate a mock improvised explosive device, or IED. After several passes over a suspected IED site, MALV lands and walks toward the target for closer inspection. A live video feed from an onboard camera confirms the location of the mock IED. In summary, we have developed a hand-launched vehicle capable of flying to a target, landing, reconfiguring for terrestrial locomotion, walking around the target area, and regaining flight by walking off a rooftop. To our knowledge, MALV is the first vehicle of its size that integrates all of these behaviors.
Micro air vehicles, or MAVs, will play an important role in future warfare. The urban battlefield calls for tools to increase the warfighter's situational awareness and capacity to engage rapidly, precisely, and with minimal collateral damage. MAVs will be integrated into future Air Force layered sensing systems. These systems may be airdropped or hand-launched depending on the mission requirements. The small size of MAVs allows them to be hidden in plain sight. Once in place, an MAV can enter a low-powered extended surveillance mode for missions lasting days or weeks. This may require the MAV to harvest energy from environmental sources, such as sunlight or wind, or from man-made sources, such as power lines and vibrating machinery. It will blend in with its surroundings and operate undetected. MAVs will use microsensors and microprocessor technology to navigate and track targets through complicated terrain, such as urban areas. An MAV operating in urban terrain will have more agility challenges than larger UAVs. Obstructions can cause wind gusts, even on a calm day. One way to overcome this is to learn from examples in nature and use flapping wings to fly. Sensing an oncoming gust, feedback control directs the wings to flap asymmetrically, compensating for the wind. Small size and agile flight will enable MAVs to covertly enter locations inaccessible by traditional means of aerial surveillance. MAVs will use new forms of navigation, such as a vision-based technique called optic flow. This system remains robust when traditional methods, such as GPS, are unavailable. Multiple MAVs, each equipped with small sensors, will work together to survey a large area. Information from these sensors will be combined, MAVs with a big picture point of view. Data will be communicated amongst the MAVs to enable real-time, reliable decision-making and to provide an overall surveillance picture for other platforms or operators. Each individual MAV may perform a very distinct mission from its fellow swarm members. While some MAVs may be used purely for visual reconnaissance, others may be used for targeting or tagging of sensitive locations. Individual MAVs may perform direct attack missions and can be equipped with incapacitating chemicals, combustible payloads, or even explosives for precision targeting capability. MAVs may carry sensors to detect chemical, biological, or radiation threats and relay this information to human operators or to other unmanned platforms like their biological inspiration. MAVs are not limited to flight. The agile hovering, perching, and crawling MAV will fulfill the mission popularly termed dull, dirty, and dangerous, like no current system can. MAVs will become a vital element in the ever-changing warfighting environment.
You know, the military is working on a cyborg beetle to use in its arsenal. Now, we're not talking about, you know, the German car, as I first thought when I heard about this. No, that little thing, that's a bug, an insect. It's part robot, part bug. Researchers have actually managed to implant miniature muscle and neural stimulators to control the creature's flight. So what's the ultimate goal here? Scott Fontaine is a military reporter at the News Tribune. Scott, thanks for being with us. All right, so the scientists take electrodes, and what do they do with them? They implant them where?
It sounds like they plant the electrodes in the brain and in the muscles, and kind of attached to the back of the beetle is it's a little radio transmitter, and the scientist standing off to the side with a remote control can tell it to fly left, fly right, fly up, fly down, everything like that.
Yeah, take off, landing, turns. I mean, it's really incredible. Can they control the beetle so that the beetle performs in a way that it would not otherwise perform, for example, sustained flight?
It sounds like, I mean, I think the beetle is still limited by by physics, what it can and can't do, but it sounds like that these electrodes it pretty much overtakes the beetle's free will, if you will, about where it wants to go.
Yeah. So what I'm wondering is, what are the potential military uses? How can we use this to our advantage?
Well, I think it's still a far way off from the battlefield. Right now, this project is being funded through DARPA, which is kind of the Pentagon's research and development wing. They give grants to things that may or may not work, and oftentimes have pretty big technological advances down the road. But even on the website for this particular project, on DARPA's website, they talk about the possibility of implanting maybe a microphone on it or a chemical sensor.
Right.
They really see this kind of as the next step in evolution between human and animal cooperation. Really, I mean, they reference the horse and buggy, and maybe
right.
A bird in a coal mine.
Yeah, I mean, you could implant a microphone on a beetle, fly it into a suspected terrorist's hut or an enemy's location, and simply listen in on the conversations and the planned attacks. It's amazing, and they'd never know.
Absolutely.
All right. Let me ask you about human applications. I mean, someday might they use this on human beings?
Well, I don't think they're quite ready to say that yet. I think insect brains are a tad simpler than humans, or at least I hope so. And
well, judging by some guests we've had.
Well, that's true.
Go ahead.
But I think we're still a ways off before maybe applying certain things to more advanced creatures, including mammals.
Yeah, I mean, it's really pretty incredible. I've also been reading they might be able to use these as couriers to get information to inaccessible locations. That sounds plausible, doesn't it?
Oh, absolutely. I mean, if you think about it, just meaning the advances in flash drives we have now make gigabytes of storage, the size of a coin, and maybe you can tape it to the bottom of one of these bugs and fly it somewhere where no one will know it's coming.